Hi everyone! In today's lesson we are looking at Chapter 7, Section 4, Translations and Vectors. Our objective is to identify and use translations in the plane, and also to use vectors to describe translations. Our standards are G-code 2, 3, 4, 5, 6, 7, and 12. Let's start with some vocabulary. First word is a translation. A translation is a transformation that maps every 2 points P and Q in the plane to points P prime and Q prime so that P prime is equal to Q prime and line segment P prime is parallel to line segment Q prime. Vector. A vector is a quantity that has both direction and magnitude and is represented by an arrow drawn between 2 points. The notation for vector looks like this, where we have our 2 points A, B, and right above that it looks like it's a half arrow to show that this is a vector. Initial point. The initial point of a vector is the starting point of the vector, and this is pretty important to know because when we start talking about component forms we want to know what the initial point is. In this case over here, this is the initial point. Terminal point. The terminal point of a vector is the ending point of the vector. So in this case over here, the terminal point is where the arrowhead is. Finally, component form. The component form of a vector is the form that combines the horizontal and vertical movements of the vector. When we show the component notation, it is usually using these arrow-looking brackets. Theorem 7.4, Translation Theorem. A translation is an isometry. Remember, isometry means it doesn't change its size. Theorem 7.5. If lines K and M are parallel, then a reflection in line K followed by a reflection in line M, so basically a double reflection, is a translation. The difference between a double reflection over a parallel line versus any regular double reflection is that if it is over a parallel line, then it's a translation. If it's not over a parallel line, then it could be a rotation. So if P double prime is the image of P, then the following is true. Line P prime is perpendicular to K and M. P double prime is equal to 2D, where D is the distance between K and M. Example number 1, translations in a coordinate plane. Sketch the image of triangle ABC after translation. We have our original XY that is translated x plus 4 and y minus 5. Basically, whenever we see a plus and a number, that means we are translating in the positive direction. So we're either moving up or we're moving to the right, depending on whether it's the x or y. And then if we see a negative sign, then we're moving in the negative direction. So we're either moving to the left or down, again, depending on which coordinate point it is. So to graph triangle A prime, B prime, C prime, we're going to be shifting each point 4 units to the right and 5 units down because it's a negative 5. If we do that translation over there, if I take A and I'm going to move it to A prime, so it is 4 units to the right, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5. So A prime is located at x equals 7 and y equals negative 2. Doing the same thing for B, move B 4 units to the right, 1, 2, 3, 4, and 5 units down, 1, 2, 3, 4, 5. So B is located at x equals 2 and y equals negative 3. And finally, taking C, moving it 4 units to the right, 1, 2, 3, 4, and then 5 units down, 1, 2, 3, 4, 5. So C prime is located at x equals 5 and y equals 0. Alright, checkpoint problem number 1 is yours. Write the coordinates of the vertices of the image after the given translation of triangle ABC. XY is mapped onto x minus 6 and y plus 3. Example number 2, identifying vector components. We are to name the vector and then write its component form. Naming the vector is really easy. You're just going to tell me what the initial and terminal point are, and don't forget the little half hat on the top. The vector is CD, and the component form of it, to write the component form, we are going to go from our initial point to our terminal point. And notice, to go from C to D, I'm first going to look at my x direction. So from here to where D is, I'm going 1, 2, 3, 4 units to the right, so it's positive, and then going 1, 2, 3 units up. So the vector form is 4 and 3, where 4 represents the x direction and 3 represents the y direction. For B, our vector is PQ, and the component form of it, now starting from my initial point going to the terminal point, we are going down. So if I was going to look at the component form of my x direction, I'm going to start where P is, my initial point, and move 1, 2, 3 units to the left. Since I'm moving to the left, this is a negative, so this is going to be a negative 3. I'm also moving down in order to get to my terminal point, so my y is going to be 1, 2, 3, 4, negative 4. So my component form is negative 3 and negative 4. Example number 3, translation using vectors. The component form of JK is 3, 6. Use JK to translate triangle DEF. Basically what they're telling you, here's your component form. You're going to take each point and move it, since it's a positive, 3 units to the right, and since 6 is positive, 6 units up. So it's basically the same thing as doing a translation. The component form of JK is 3, 6, so the image vertices should be 3 units to the right and 6 units up from the pre-image vertices. Graph and label the image vertices, then use a straight edge to draw a triangle D prime, E prime, F prime. So let's find out what our vertices are for D prime. So we said that we have to go 3 units to the right and 6 units up. 1, 2, 3, and then 6 units up. 1, 2, 3, 4, 5, 6. D prime is located at x equals 1 and y equals 3. Doing the same thing for E, moving it 1, 2, 3 units to the right and 6 units up. 1, 2, 3, 4, 5, 6 gives us 1 and 5 for E prime. And finally, looking at F, 1, 2, 3 units to the right, and then 1, 2, 3, 4, 5, 6. 6 units up gives us 6 and 5 for F prime. Alright, checkpoint problems number 2, 3, and 4 are yours. For each of these problems, you have to write the coordinates of the vertices of the image produced by translating triangle ABC using the given vectors. So we have vector of negative 4 and 8. We have a vector of 0 and negative 6. And we have a vector of 7 and 0. Alright, that's it from me. I'll see you all soon.